All right, congruent shapes. Now I know we're talking about similarity in chapter 3, but what we need similarity to do is to help us form a great understanding about what the word congruent means. So if two figures have the same shape and are the same size, they're congruent. And since the figures must have the same shape, then we can also call them similar. So similar figures that didn't change. So we did a couple of those this week where we were supposed to um, dilate a shape by a zoom factor of 1. And a lot of us said, well, it doesn't change for a zoom factor of 1. And what that means is that when you're not changing anything about the shape except recreating it, or you're multiplying every side by just 1, then you're actually creating a congruent shape. And that's what that zoom factor or scale factor of 1 should mean to us. It means, oh, I'm creating a shape that is congruent. So conditions of congruency. Two figures are congruent if they meet both of the following conditions. So if they are similar, so that has to be first and foremost. If I can put all of their side lengths, so let's try that. All of their, oh my goodness, all of their corresponding sides, so 9 to 9, let's make them match. 9 to 9, is that equal to 10 over 10? And is that going to be equal to 5 over 5? And of course, hopefully you're rolling your eyes and saying, why do I have to look at this video? Because yes, 9 divided by 9, 10 divided by 10, 5 divided by 5, they all give me a scale factor, zoom factor, a ratio reduced to 1. So does that mean now when I have triangles that I go find the matching numbers and divide them and say, well, look, they're all similar? Well, no. The reason that we know that the two are similar is when we look at the corresponding sides. So 10 is between these two angles that one's hashed with 3, one's hashed with 2. We come over here. 10 is also between the angles that are hashed with 3 and hashed with 2. So our corresponding congruent angles are also clues as to which sides correspond to each other. And that's something else we have to make sure that we pay attention to, is the angles clue us into which sides we consider are corresponding. We definitely know which angles correspond because they're either going to have the same measure or have the same markings. But then in order to figure out which sides correspond, use your angles as a roadmap to help you figure out which one am I supposed to be in a ratio with. So the two figures are similar. Yes, they're similar. They're reduced to a scale factor of 1. And if their side lengths have a common ratio of 1, then we can also comment and say they're congruent. So these two things need to happen, but one condition, the last one, comes from the other. So when you find out if they're similar and you get this ratio, then kind of scratch out that word similar and say, no, they're also similar, but more importantly, the two shapes are congruent. So this is where we're going to be developing now from similarities. We're going to start talking about congruent shapes. And can I say that these two shapes are exactly identical based upon their scale factors? So now what I would like you to do is to draw a star up in the corner of your paper with um, exclamation points upside down to prove to me that you watched this video on congruent shapes.